You're an alien species, hypothetically, and you come to this planet, and all that I tell you to do is get the first life that you take. Like, go to the planet, get life of some sort. What animal are they going to have? Pretty good chance. It's not going to be grass. It's a good thought, though. Not going to be grass. Although grass is alive, it's a plant. What do you think is the most common life on this planet? So bugs, maybe. There's trillions, literally trillions of ants on our planet, but it's not ants. It's not insects.
Isn't it something surprising like chickens?
It is not chickens. Say it again? That's a good thought. No. Nematodes. Nematodes. They're like bacterial moss and worms, like worms would fit into it. Most worms, small worms like parasitic worms that you find in river samples and stuff, those are probably in the nematode family. 70% of all life on this planet is a nematode. Cool. All right. So that links perfectly with mathematics because today, there we go, we get to talk about Chapter 2. And within Chapter 2, we get to have our focus kind of honed in, at least a skosh. Chapter 2, we'll be talking specifically about functions and I think some of the more interesting ones. So we, over the next however many classes, 2 weeks roughly, will be discussing polynomial, which I would suggest I never want to write polynomial again. Poly, if in regard to a shape, polygon. If in regard to functions, polynomial. We are going to be talking about polynomials and rational functions. Now, I'm going to leave an awkward gap here, and I'll even put some parentheses. Rational func. Rational has a root word of ratio. What's a ratio? It's an F word, not that one, but it's an F word. So that's one of them. It's not vector. Fractions are ratios. Now, fractions are really just division, right? And division, the answer is a product is the answer to a multiplication. What's the answer to division? A quotient. So remember, rational, if you want a shorthand, it's this blackboard Q. Or, as you guys, I think, looked at me like I was crazy if that was this class, the circle with an H in it. But it's a Q. Blackboard Q. All right. Now, when we talk about these things, as with everything, when we write them in the general form, they're ugly. Some of this stuff is going to be repetitive because I knew we were coming here and I just tried to preload a little bit. Starting in 2.1, we will talk about our most basic polynomial functions other than linears, which are monomial. 2.1, our focus today is going to be on quadratic functions. Quadratic functions. All right. Now, this is going to feel weird, but we are actually going to zoom out just a skosh. Quadratic functions, and I don't know why I put my notes down. They are a special type of polynomial. So as we look at these, remember, if I have a function, and I'm in white, don't write. If I have f of x equals 5, is that still a function? Does it ever change? So what do we call it then? It's a what function? Constant. How about if I have something that looks like this? And I won't use that. We'll do this. 2x plus 3. And this is going to feel odd, but that. 2x to the first is what's really there. That's a function too. It's what sort of function? A linear function. The next step up from here is just simply going to be our quadratics, right? What's after a quadratic? Cubic. Do you know the fourth? Quartic. And quintic is 5. Now, we will see all of them, but I just want to remind us that when we actually write them, they're not near as ugly as they're going to seem for a brief moment. So to jump into this, if we're going to be talking about the graph of these things, which we will, we're going to sneak in with the definition right off the bat. We probably already have this written down, but we're going to define for ourselves a polynomial function. Polynomial function. If you would rather, polyfunc is a pretty good way to write it down without having to write a bunch. Polynomial function. We need a good working definition that is formal. So, when we do these formal definitions, I'm going to read it out. Inevitably, somebody's going to see a word and not know what it means, and they're going to have the urge to not tell me that you don't understand a part of this. But we're all going to do what? the second there's something you don't understand. Tell me or ask a question or whisper loud enough to your neighbor that I can hear it and interject myself into your question. Cool. So we're going to start right off the bat. We're going to write the following. I want to just see how much you remember. I'm going to say let n be a positive integer. Could I write that word for word? Like literally I could write, quote, let n be a positive integer. Now, if only there were a way to say that n belongs to the set of positive integers. What belongs to the set of or in the set of? This lowercase sigma. Okay, epsilon, I lied. It's not a sigma. What am I talking about? Let n be in the set of integers are the z's. And if I want it to be positive, what little superscript should I put here? Plus. Let n be a positive integer is what is written on the board right here. Okay, we have n being a positive integer, and beyond that, we're going to let the following ugly notation exist. We're going to start with a sub n. This is going to be a number, but if we start our list at n, we're just going to start counting down. A sub n minus 1 is next. If I wanted to write the next, what would it be? A sub what? N minus 2 and n minus 3, so forth and so on until I get all the way to the end of my list, right? So eventually, I'm going to put dot, dot, dot. These ellipses just indicate, hey, there might be stuff missing. Eventually, we're going to get down to a sub 1. Whoop, I don't know why I looked there. A sub 1 and a sub 0. We're going to let all of these things just represent indices. Now, all I mean by that is they're just numbers along the way. Specifically, these are going to be real numbers. So we'll say in the set of reals with one requirement and only one requirement needed. We simply need to make sure that a sub n is not equal to 0. Okay. Looks ugly, probably. It's not. N is a positive integer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Don't care. A sub n all the way through a sub 0, they're just real numbers. 5, 2.6, 7, doesn't matter. They're just real numbers where this can't be 0. We have the function here, and I'm going to leave a very specific cliffhanger. The function, and I'm going to censor this, f of x equals, what's the first number that showed up in our reals? A sub what? N. That's going to be our first coefficient. And it's going to match up with some power of x. And we'll just say it's x to the n in this case. Plus, what's the next coefficient down the list? Okay, good. And again, when I say these are indexes or indices, I'm just saying this n or n minus 1 is how we keep track of the specific number. The n term, or a sub n, linked with x to the n. What do you think x to what power links up with x to the, or sorry, a sub n minus 1? Am I being too abstract mathy? A sub n, x to the n. A sub n minus 1, x to the n minus 1. Plus, I'm not going to write this next one because there's infinitely many possibly. It would be a sub n minus 2, x to the n minus 2. And we just see that, hey, this number, a sub whatever, links up with this power of x. That's all that's telling me. Okay, and eventually we're going to get down all the way to a sub 1. And x to the what power here? To the 1. Am I going to write it? Would you write first power? I don't believe you. But I'll write it for now. And the last one, plus a sub 0. And I'm not going to write this one. I'm going to write it in green. Don't you write it? Why don't I want you to write x to the 0? It's 1. Like, this is just a function that ends with a constant, right? All that this is saying. Okay. That looks ugly. This thing, this function, has a specific name. This function is a polynomial function. And I'm just going to start writing polyfunc of degree. What's the biggest power of x that shows up in this list? So bigger than 1. N. Unless you said what, and I just didn't understand you, Rafa. Okay, the biggest power of x is x to the n, and then everything after that is a smaller power of x. This is a polynomial function of degree n. Okay, so as we look at this, I want you to identify the following. A quick example, I just want you to tell me the degree, and this is my shorthand, but I would bet dollars, American dollars, that if you go to any math teacher, they'll know what you're talking about if you write this. I want us to find the degree of each function f of x that we have. Okay, looks ugly. Promise it's nowhere near as ugly as it looks, and realistically, it's purely an aesthetic thing. It's actually really nice and generalized, but you might not feel that way yet. So here we go, a couple easy ones. I want f of x, and I'm going to throw you a curveball on one of these. Let's say it's 2x to the 5 plus 3x cubed plus 1. Nothing too crazy. Now, in this case, what would n be if we're looking back at that general definition of polynomials? It's the exponent, and specifically it's what? 5. So a sub 5 is what number? And this is where it feels weird when we talk about it. What's the number connected to x to the 5th? 2. Cool. So we've identified the n and the coefficient that goes to that x to the n. Now, the next one down would be x to the 4th. It's here, but I don't write it. Because what's a sub 4? That makes this completely irrelevant to write down. My first a value was 5, or 2, I'm sorry. The next a value that should be with x to the 4th, because we just count down. Why don't I write it? How many x to the 4ths are here? 0 of them. Could I write plus 0x to the 4th? So notice if we start at 5, what's the next power? Good, so 5 minus 1 would give us 4, and then the next one would be 3, 2, 1, all the way till we don't have a variable. I just want to highlight here that these are all the same pieces. We just don't have all of them filled in. Now, if we look at just a degree, can you guys identify for me the biggest power of x? You will not be wrong. JV, what's the biggest power you see on any x term? Boom, the degree is 5. We done. Okay, I don't think we need to talk another one out. I'm going to write one here. I want you guys to determine this. F of x this time. Let's say it's negative pi x to the 4th plus 3x cubed plus 7x to the 5th minus 1. You can probably answer it in a shorter time than needed to write it down.
It's just the biggest exponent.
Yep, the biggest power of x, it shows up. Now there's something annoying about this problem, I think. Maybe it doesn't annoy you guys. If you answer 4, you've fallen for my trap. The degree is not 4, because this thing isn't written the way that polynomials should be. What's the degree of this function? Indeed, right? And I can see it's right here. It's out of order. You may not have noticed, you probably did. It'd be weird for that to happen, but could it? Yeah, and in fact it just did. We saw it. So here we go, the degree of this function. The degree of this function f of x was what again? 5. What is a sub n for this function? 7. Because it's what's connected to x to the biggest power. Or a sub 5 is how I should have asked that. You're good. I'll just get louder. If I have to! Anyway. All right. Was it this class or the other class where we talked about memes? Okay. Monday, bring me your favorite meme. I'm going to pick a winner, and I'll show all my classes that meme. Bet. Cool. All right. So here we go. These are all fine and dandy. Now, these as degree 5 are bigger than the functions that we're really going to look at. We are looking at what sort of function if you check back in your notes? Okay, you're right. And we talked about polynomial functions because there's a particular, like these were both polynomials. This is a quintic function. What do we say we're focusing on in this section? Quadratic, so check it out. We better define quadratic real quick. Now, your book from time to time will use the term squaring functions instead of quadratic. I hate it. It works, like I see what it is and I get their language because they're using x squared, but there's just something that doesn't feel right about it for me personally. So we're going to define a quadratic function. Okay, as we look at this, really easy. What's the biggest power of x that we're going to deal with? So they're all degree 2, which means you're going to have, at the very largest, x squared. No x cubes are allowed. You'd be a cubic function at that point. They all have degree 2. So we're just going to say, have the form, and we're actually going to make it a little more specific. We need, at most, let's see, x squared, x to the 1, x to the 0. At most, it's a trinomial. Because if I count all the way down, I have variable, variable, constant. I'm at the end of my list already. So we only need 3 letters. We primarily use A, B, and C. So what should we require about those 3 numbers? Not lat. Let A, B, and C belong to the real numbers so that we don't have any imaginary I stuff going on. Where, or with, if you will, the only requirement I'm going to have is A cannot be equal to 0. That's it. If we have this, then, and I'm going to center this again very intentionally, f of x equals ax squared plus bx plus c is a second degree, but I'm not going to write that word here. How would we call it? Instead of saying it's a second degree function, which is correct, let's say what sort of function? Quadratic. Okay. Nothing too crazy, I don't think. Now, as we look at this, we are going to be graphing, but we're going to try to graph more maybe quickly than we can in other situations. So, couple quick statements that we can make about it, and we'll write them down when we get to the graphing part. If I were to give you this graph in white, don't write this down, okay? Don't write this part. I just want you to show me with your arms as roughly as you can. Give me an upward parabola. Okay, give me a down parabola. All right, easy. Weird shape there, but that's okay. Okay, I just want you to really quickly tell me if you can tell what each of these graphs will at its most basic look like. Show me with your arms. How does that parabola look? You don't have to worry about the size and width and stuff. Why? It's positive. What if I do this? Negative, right? Like, we can do it. That's a much better idea. Way to use that old computer up there. All right. Now, as we're talking about quadratic functions, because we've already dealt a few of these, we'll talk about it. As we're looking at them, couple things. I'm going to use an asterisk here instead of the dash because dashes look like minuses. Cool. So, first thing, we talk about the leading coefficient. Can somebody remind me, I'm not going to write it as a true vocab, but is this language familiar to you? Leading coefficient. What is it? Okay, the number in front of the highest powered variable, or the number, the coefficient, that's the number, associated with your degree term. Now, that's really formal. As we look at this, we'll just say, in the case of quadratics, it is what out of these? It's A. The number connected. Now, realistically, I should say the number connected by multiplication, but I'm just going to say connected to x squared. All right. You guys, I think, have demonstrated this. 2 possibilities and why I even care about this leading coefficient right now. So here we go. If A is less than 0, how does our parabola look? So here's an A less than 0. How did you make that parabola? Downward. If A is less than 0, f of x opens downward. Okay? And now I can use dashes. What if A is greater than 0? Good, I think. Now, you guys, I appreciate the heck out of seemingly you write down almost everything that I do. I would encourage you, as long as you understand what your notes are saying, use shorter stuff. If I were taking notes from me, which, gosh, I wish. No, okay, all right. I would do this. If a is greater than 0, shah. If a is less than 0, shah. Like, that gets the same idea across in my mind. It might not in yours, and that's okay indeed. Okay, cool. Now, I'm not going to make you graph these yet. We've talked about the translations and stuff. We have this form. If I just asked you guys to graph by hand some random parabola, could you? Could you make a table and graph it? Probably. Now, there's an issue, because real quick, I'm not going to make you do it. We're going to see the issue, and we'll talk about it as it arises. Have I said anything today that gives anybody pause, and you're like, oh, I don't really get what we're doing? All right. So, everybody's favorite thing's about to show up. You guys like or don't like factoring? Like, honestly. It's okay for some of you. You don't like it? Okay. My hope is that you will, whether you like it or not. Do you hate it? You can say yes if you do. You don't hate it. It's just meh. Would you rather factor or graph? On a scale of 9 to 10, how much do you guys love factoring? No, that's not the scale. 9 to 10. That's a tricky question. All right. No matter your answer, it looks good, right? Cool. Real quickly, I don't know if you guys noticed last night, but the Cowboys won. All right. Okay. All right. So, what I'd like is, you have seen this before, but you're probably rusty. We are going to sneak in. We're still talking about quadratics, but rather than just talking about them from a polynomial standpoint, functions of degree 2, that's really all that we need to say. We want to talk about the standard, or there's a few ways you can see this. I like to use interchangeably with standard. I will use vertex, standard, or vertex form. Okay. When we graph parabolas, I can tell you immediately only this part of the parabola. The rest of it, the plus 3x and whatnot, I don't know the impact on it. I know if it gets like bigger faster depending on a, or if it should be wider, but the x and the constant don't tell me a ton. The constant does. But I can't graph these things in my head either. Now, I also don't really love making tables by hand and having to work that all out, because goodness forbid, can we just agree, if it's white, don't write? That'll just be the notation. Okay, and eventually I'm going to forget it, but today that's what we're going to use. If I said graph a parabola and didn't tell you anything else, pretty commonly you're going to pick what as your first value you plug into a table. Pretty commonly it's going to be 0. Is it possible your parabola is like this, and this is 10? And now the only points you got were here, 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 and here, because you picked 0, 1, -1, 2, and -2, and you only got these 5 points. That doesn't tell the story about the parabola, right? So when you're actually graphing a parabola, what should you put in the middle rather than just 0? Do you recall? You might not know the exact name of it. You tell me when, you holler and tell me when to stop when I get to the point that would like make the most sense to have in the very middle of your table. Ooh, this one doesn't have it. The minimum in this case, it'd be the vertex, right? This is what should go in the middle. What was the name of that form that we're about to look at? Vertex form. So if we could write parabolas in a way that I could see the vertex immediately, the other points would be a piece of cake to get. Now, going through here then, the standard form of a parabola or of a quadratic function is going to appear as follows. And this is an easy definition. First off, it is f of x is exactly equal to some constant a times, we have the difference of x and h, so x minus h squared plus k. It is my hope that this looks kind of familiar to y'all. At least a little bit.
Can you go?
All right. Maybe not from Algebra 2. Maybe from Algebra 2. Hopefully from this year. Where have we seen h and k showing up anywhere before? So we did see it just now, right? But we also looked at it when we were talking about moving parent functions around. H impacts my graph how? Horizontally. And then I didn't write it, but I always do the stupid thing where when I teach this in Algebra 2 or whatever, K is for vertical, and I spell it with German with a K. vertical with a K, horizontal for H. Now, in this, turns out there's some really awesome stuff that either we can investigate it or I can just tell you. I'm just going to tell you because I think that it's not going to add a ton if we do it the other way. As we check this out, we'll say here's our standard form where shot in the dark. HK on a circle represents an important point. What was it? So it's a center. Now, parabolas, I would argue, don't really have a center. You guys probably loved talking about your directrix and all that stuff last year when you were doing conic sections for... Maybe not. Okay. What do you think HK is the important point of on this? The vertex. What do you think A might be? Now, you don't actually have to FOIL it out, but check out what happens. If you were to FOIL this out, you're going to get x squared minus 2xh plus h squared. And then you're going to distribute the a through. There's a lot of math happening. All I care, can you do the first? X times x would give you what? And then you multiply by a. So what does this a wind up representing here as well? The leading coefficient. How am I going to write that down? Because I don't want to write that word over and over and over. LC is the hollow way of doing this. Just so you guys are aware. This is not accepted. Other teachers will probably pick it up if you happen to transfer tomorrow for whatever reason. A is the leading coefficient. Now, as we deal with this, turns out from this form, unbelievably easy to graph. And we'll graph one here in a second. But how often is it you think that parabolas get to be in this form? Not usually. Normally in the ax squared plus bx plus c. So what we're going to do is I'm going to make a little note or comment, and then we're going to do a couple examples where we're going to find standard form, but instead of me saying like, oh, here's the general form and let's play around with it, we're going to see if we can just really detailed annotations to make sense of how this works. And some of you will probably remember it. Okay, to get this form, I'm going to, STND is my shorthand for standard. It doesn't save a ton of time, but I'm going to use it. You can if you want to. To get standard form, we get to complete the square. All right. That language sounds kind of familiar, yes or no? Just thumbs up, thumbs down. Y'all remember hearing complete the square ever? Okay, so we're about 50%. That's okay. All right. So we're going to make a couple things here that I'm just observations, and I'll write them down before we do this. We're going to do one together. Did you guys, I'm sure I've asked you, did you guys use factor tiles when you learned to factor? So if I wanted you, do you ever remember doing something, if it's white, don't write? Do you ever remember doing something where we say that, hey, look, this is x, and you have a tile in front of you, like, physically touch it. This would be x. This would be a 1. And then this big one would be what? X squared. Do you guys ever remember doing something like that? Okay. Some of you do, some of you don't. Was it helpful for you? Okay, so maybe, maybe not. I don't typically do this. If we need to go get some tiles, I can reach out to Jarvis, and we can play around with them. But I think if you want a picture, I can draw one. But let's get going. On this situation, in this form, notice, directly connected to the x inside the parentheses, what number's in front of the x? Not outside, but inside. So notice, and I'm going to write this down, in f of x equals a, and I'm going to leave an awkward space here, x minus h squared plus k. I left an awkward space because there's something connected to the x that we just don't even bother to write. It's a 1, right? We always have a 1 right here. This is 1x. Now, we will always do this because we want it to be a and then 1x minus h. It's just redundant and unnecessary to write the x. I wish we'd thought about it earlier. We could have all switched one little place and seen if Riley noticed, but it's too late for that now. Okay, here we go. We are going to find standard form, and we're going to do an example. Do you guys have all this written down? Cool. So our example, 2 things, and actually probably 3 things. For our first example, and really this is the big example. Example, I want us to standard form, so write standard form. And I'm just going to use stnd. And then I want us to identify the vertex, which, everybody cool with ID as identify? Okay, we're going to write in standard form. We're going to identify the vertex and sketch. Now, notice there's a difference between sketch and graph. Graph is a time-consuming process where you construct a table and do everything perfectly. Sketch is, you might do some of the same stuff, but you're not going to put near the amount of time and effort into it. Okay. So, who's the coolest person in this classroom?
What is that? That
Identify. So I'll change that.
and is STND supposed to stand for standard form?
It does. Write standard, identify vertex, and sketch. And I'm trying to, if I write the whole word and then we spend 2 or 3 minutes talking about my shorthand, it doesn't really serve the purpose. But I'll do better. I'll try to do better about it. All right, so here we go. On our first one, let's say that we get this lovely function f of x is, I don't want one that's too ugly yet. 2, and then in parentheses we'll have x minus 4 squared, and then plus 1 on the outside. All right, now I'm going to treat each of these when I'm writing my stuff. 1 is standard form, 2 is vertex, 3 is a sketch. Okay, so let's check it out. Step 1, can you guys make this standard form? I'm going to pause. Everybody can, depending on how you think of that verb. Everybody can do this. Talk it out. Find me the standard form of this. Okay, so that part's easy. F of x. And this feels silly to do, but it's the exact same thing. X minus 4 squared plus 1. All right, cool. Done. Did everybody notice that right off the bat? Okay. 2, I want the vertex. What am I subtracting from x? X minus what? 4. So I'm just going to say vertex, which I normally write just vert. Vertex equals the ordered pair. You said it was a what that I'm taking away from x? 4. And what is the value of k? 1. All right. Got it. Yo.
Oh, just kidding.
What was your question?
HK.
You could, that is also a good way to do it. Absolutely. I avoid it only because we just talked about circles. Okay, step 3. We're going to graph it. Now, for this, you can use your calculators if you want. I think it's a waste of time. We're going to be able to do it faster without calculators here, and I'm not even making it up. I'm going to make a small table, but it's not going to be like crazy detailed. So, right off the bat, I'm going to draw my table first. We have x, and then I'm going to do scratch work in the middle. If you do all of your work mentally, I'm cool with that, but if you get it wrong, you get no partial credit, just so you know. Did you guys use 3-column tables last year? Okay. Somebody gave me a nod, so I think yes. All right. On a parabola, there is symmetry. And we didn't write that down, but I know that we've talked about it. Parabolas always have symmetry, right? If I get half the parabola, do I get the other half for free? Because you just reflect it over the vertical line that runs through the vertex. It's just reflected over itself. Okay. I only need 3 values for this thing, and I already get one of them for free. So I really only need 2 more points. And that will make a total of 5. We'll talk about it. You write your first point here. What's the first x you're going to pick? 4. Now, I'm going to leave it here. I'm going to write it in the middle, but I want you to write yours right on the very top, okay? 4. Now, without doing any other work, can you guys tell me what it spits out? It's going to be 1. I know it, but I'm just going to confirm, and I will switch to yellow stuff in the middle. If I plug in 4, I get 2 times 4 minus 4. I wish I had a really fast color change button. Squared plus 1. And what's 4 minus 4? 0. So I get 2 times 0 squared plus 1. What's 0 squared? 0 still times 2 is 0 plus 1. Hey, look. We said it was going to be 4, 1, and it is 4, 1.
Why'd you start with?
So, because when I'm doing mine, I notice I put it in the middle. I want to be able to use the vertex because, and this isn't our graph, but check out what we have. If I have a parabola that looks like this, hypothetically, if we know the vertex is here, and then I find this point here and this point here, which is what we're about to do, I know that every parabola reflects over its vertex. If I get just these 3 points, I know that the other part's just going to be right here. Now, I want you to have 4 on the very top of yours. Mine fit in the middle, but that's okay. So check this out. Give me another number you might plug in that's easy to plug in and evaluate with this. 4 worked really well because it made me square the number 0. Should I plug in like 4.63? No, because what's 0.6? 2 would work, but there's an easier one.
1.
Easier.
0.
Easier. You're going the wrong direction. What's the easiest number to square after 0? 0 squared is easy. I got it. It's 0. The next easiest one? Is there a value of x, and somebody said it, but I just want to make sure we get it. Is there a value of x that you could pick that would make inside this parentheses be a 1? 5. Now, when I pick 5, notice I'm going to skip some work here, but please let me know if you need more. When I plug in a 5 for this x, it makes everything right here 1. We have chosen 5 specifically to make this be a 1 because that's really easy to deal with. Everybody cool with that one? Okay. What's 1 squared? 1. 2 times 1 plus 1? It's 3. Now, my table, I wrote too much work here, but check it out. I know that if I went 1 to the right of my vertex, I went 2 up from my vertex. There's a lot happening there. If I go 1 unit to the right, my graph goes 2 up. Now, I know that parabolas are reflected, right? You do not have to include this point, but if you wanted it to look like the standard 5, if I put a 5 here, a 3 would be here, right? Because I'm the same distance away. Without doing any math, can you tell me what point I'm going to get out when I plug in 3? I'm going to get 3 again. Because, remember, if I have, and we can actually put this point on, but I'm not going to spend a whole lot of time. If we identified 4, 1 right here, and then I identified the point 5, 3 that lives right here, I know that as my vertex, my other point's going to be right here. It's just going to reflect. I get it for free. I don't even have to write it down. I've just done so for your benefit. Okay. Question? Yeah. All right. One more point. We're not counting that one as a point. Just kidding. That one as a point. 0 was pretty easy to square. That's why we chose 4. 1 was pretty easy to square. That's why we picked 5. What's the next easiest thing? 2 is easy to square, right? What value of x would you plug in right here to make it a 2 inside? If we plug in a 6, we now get 2 times, and this is where we may vary. I have no issue if you want to show all the steps. What would I normally write here, do you think? So that's a great thought. I would not. Can you guys, if we didn't do 2 times 2 squared, if you would rather, do I think that all of you can square the number 2 in your head? Do I have an issue if you just jump here? I'm good with it. Because you're always, if you pick the right numbers, you're always going to square 0, you're going to square 1, and you're going to square 2. They're the easiest possible numbers. Now, what's 2 times 4? Plus 1? 9. Now, I want to graph this parabola. We have as much information as we need. Let's take a look. I'm going to do mine down here. Now, are we graphing or sketching? Oh, thank goodness. Okay. Now, tell me, which quadrant or quadrants am I primarily linked in? Mostly quadrant 1, right? Now, you will not always use it, but the one thing I want you guys, rather, two things I always want you to show on your work is I want you to show the x-axis and the y-axis, like every single time. So I'm not going to use little tiny squares here, but I think that reasonably, if I'm sketching, that could be 3, and I have to go at least how far to the right? Why 9? 6 to the right. 9 up, because this is my y values. Okay, so there's 3 and 6, and I can eyeball out 4 since we're just sketching. In the y direction, Sean, what do you want to go to? So what should I jump by based on my grid that I have?
3.
I could go by 3. Could I do this too? Does that make sure I can see all the way up to 9 and all the other values? Coincidentally, my grid is also 5 by 5, so that's like perfect for me. Okay, check it out. When we draw this, and I'm going to use yellow to actually draw the points. 0.41. If I said this is 4, would you believe it? Okay, cool. There it is. I meant to do yellow. Here's 0.41. Okay, and then I get the 0.53, which if that's 4, this is probably 5. And I'm just eyeballing them. 5.3. Man, it's really hard for me to see these little grids on my computer. And then one more, I get 6 and all the way up to 9. This is what I have graphed at this point in time. Why is that so helpful? It literally just reflects. Go the same distance over, and it'd be there. Go the same distance over from, now when I say over, just to be super duper clear, here's the vertical line that runs through my vertex. We'll try again. There's the vertical line. It's off the opposite direction. All right, it's close to vertical. We're just going to say that's a vertical line. I am just reflecting these points over. This point reflects to right here. This point, if I just eyeball it out, looks like it reflects to, I don't know, maybe there. Would you believe it? Looks like it. And then we connect. Now, this graph is kind of steep. Here's the one thing that I want you to be really careful of. Tell me what I've done wrong. And why do I hate it?
Straight line.
It's a straight line-ish. I missed the points, which that'll happen on mine. It doesn't happen with me on paper, but this thing's challenging. Try to make sure that it looks like they might be kind of steep, but try to make it look at least kind of curved. Okay. This is a silly question. Do you feel that that's much easier than doing ax squared plus bx plus c stuff? I hope so. Now, there's a challenge hiding in here, though. We are going to have a short assignment over the weekend, like it's going to happen, and we're probably not going to have much time in class. Super short assignment this weekend so that you have time to work on your reflections if you want to. But we need to work on a very specific factoring technique that I know doesn't feel like factoring yet, but we're going to do a big problem together, and we're going to annotate the crap out of it. So, because we're going to put so many annotations on it, if you're on the bottom part of your page, I would turn your page for this next example. I would turn yours. It's not going to be like a whole page of work, probably, but this one might have been a whole page of work. Okay. So, I made a comment before this example that to get into standard form, we do this really fun technique that about half of you remembered hearing. We complete the square. Okay, so check it out. This is going to feel rusty for you guys. I'm going to give us a nice one first. G of x, let's say, is equal to 2x squared plus 4x minus 5. And I used 2 before. I'm going to use 2 again. I don't care. That's fine. Now, if you wanted to graph this just right from here, you certainly could. Can anybody tell me where the vertex is without graphing it, though? Like, what number goes in the middle of your table? That's right. It's -1. Okay. Now, you might not know that, and you might not recall or see how I get that. That's okay right now. We will see it. My goal is not to have to graph from this form. There is a way to do it, but the tables are a little bit uglier. Here's the big annotations, and I have enough room. Okay, we're going to annotate the heck out of this. First thing, I can add parentheses anywhere I want. Do you guys agree with that? I'm the boss of parenthesis land. You're your own bosses of your own parenthesis land. We can add them wherever we want, as long as we don't change addition to multiplication and so forth and so on. Okay, I'm going to Would you rather I write the little thing that I'm doing here in green, or do you want me to do it here and then I'll write out what I did? So we'll switch back and forth. I want to group only x terms together. Now, when I say group, that says I get to add what? So careful, what do you mean? When you run through GEMS, which maybe you guys didn't. Have you guys all heard GEMS for order of operations? Oh, it's so much better than PEMDAS. P in PEMDAS stands for what? What if they're brackets? It's not PEMDAS. Like, G in GEMS is grouping. So the top of a fraction is grouped together whether you put the parentheses there or not. Inside of a radical symbol is grouped with parentheses whether you write them or not. GEMS work so much nicer. G for grouping, however it fits. E for what? Exponents. M for what? M for multiplication, and S for, now there's a natural question. If we have, you're right, if we have grouping, exponents, multiplication, subtraction, and you compare that with the old-fashioned PEMDAS, we left off some stuff, right? Did we really? Like, seemingly I've left off division and addition, right? I'm going to claim I haven't. Why? Dividing by 5 is the same as multiplying by what? Say it again. Why do I have an alarm going? So I'm due for a foot surgery. Yeah, I'm going to have foot surgery maybe over Christmas break. They're calling, but they apparently don't understand when I tell them what time I'm teaching. Okay, sorry about that, guys. Yeah, I have a weird form, like, I have a bunion, not like an old lady disease, for lack of a better thing. So, do you guys know what a bunion is? They can look awful, and sometimes they're really gross. If you have, let's say this is my big toe here, and I'm just going to let this one be my big toe. Sometimes just because of shoes that we wear as modern people, or maybe I walk funny, I don't know. Sometimes that joint gets pushed out and your toe starts to turn. And they can be really gross and terrible. Mine aren't, I don't think, but I'm not going to show you my feet for you to decide. They can turn out, and it turns out, like, I'm not going to show you my feet, but right here, like, I think I have normal looking feet, at least in a sock. But you might be able to tell, I will show you my feet, I lied. Okay, nothing bad about it. Do you guys see that there's like a bulge right there? That's my joint popping out to the side. So it causes pain, which I've been dealing with for several years. But figured, why not get rid of it? So they're going to cut out some of my bone, which is pretty cool. Anyway, multiplication and division are the same thing. You don't need to list them both, because when you really write PEMDAS, you guys probably saw it like this. P-E-M-D-A-S. Like, that's how PEMDAS really should be written. You could call it PEMA or PEDS. It would work all the same. GEMS covers all this without having to worry about those silly things. Multiplication is the same thing as division. Subtraction is the same thing as addition. It covers it. Grouping then links up with what? Parentheses. Okay. I can add parentheses wherever I want. I want them around the x terms. We're going to get real crazy real fast. Check it out. I'm going to keep yellow if that's okay with you guys. G of x is now equal to 2x squared plus 4x minus 5. Notice the spacing. Brah, brah. X terms are together. Okay. Look back at our standard form. We made a big important comment. What inside of my parentheses do I want to be the coefficient inside of my parentheses connected to x? Not a, inside the parentheses. So don't guess, I'll go back over. Inside the parentheses, and you might have been out. But check it out. Okay, here it is. Notice, inside the parentheses, what's connected to the x? We need it to be a 1. Okay, double back to this. What's connected to my x?
2.
Ah, sucks. Well, if only there was some mathematical operation we could do to make that happen. Factor. In this situation, I'm going to say 2 or I can write the leading coefficient out of parentheses. Do you want me to write the 2 or LC? I'm going to say both. 2 in this case. Out. Because I want it to be a 1. Now, notice this group was not arbitrary. It feels like it might have been, but it wasn't just randomly chosen. Parentheses around the x terms. If I factor out a 2, what happens? We get 2 there. What stayed inside? X squared plus 2x minus 5, and now I'll add my parentheses again. Okay. We are slowly working our way. Does this start to look closer to that standard form? Starting to. Now, here's the big part. Our completing of the square. This is going to feel like a really wonky question. Maybe not because we have used it before. What can I add to an equation that doesn't change it? The identity, we could call that, for addition. I can add a 0. I could say plus 0. That doesn't do anything. Give me another way to write 0. Plus 5 and... No, that won't do it. Minus 5 would do it, wouldn't it? Plus 5 and minus 5, if I do that in an equation, I'm really and truly adding 0. Now, we get to add a 0, but it's a very particular case of 0. When you complete the square, our goal is to make this thing inside parentheses a perfectly square trinomial. Now, to do that, we can play around with factor cubes if you want. I'll get some. We can look at it on Monday. But we just need to know what the last number needs to be here. That's all the goal is. Now, we're going to take this b term inside the parentheses, which is what? 2. We're going to take that middle term connected to x. So I need to write this out as few words as I can. Take the coefficient on x. Notice, did I say x squared? I did not. Take the coefficient on x. In this case, what is it? Inside my parentheses still? You're going to give me one of 2 answers, and they're both right in a different way. What's your guess here, Rafa? Okay, sorry. What's the coefficient on the x inside of my parentheses? 2 in this case. Okay, we're going to take that. We're going to divide it by 2. It's 2 every time. It's a coincidence that that's also that number. Square it. Then, last little step, add and subtract inside the parentheses. Inside the parentheses. Man, parentheses is a really ugly word. All right. Sorry that I can't be less wordy there. Help me out with this, though. I'm going to have the scratch work underneath. In this term, what is the number connected to it again? Connected to the x? Okay, so we'll take that 2, and I wish I had a good way. I'm just going to recopy this line. You don't have to, but I want it to be really clear in my notes. So if we take this, here's me doing that exact step, just so you're aware. I take this number, 2, and I divide it by what? I divide it by 2, so this number is 2 divided by 2. I'll put parentheses around it and do what? Square it, and then let's just see what that is. What's 2 over 2? So that's 1 squared equals 1. What do I do with this number? So I took the coefficient, done, divided by 2, double done, squared it, triple done. To get quadruple done, what do? Add and subtract it inside the parentheses. Now, you will see that this step kind of combines when we actually do these to save a little bit of writing. But we're going to rewrite this again with a buttload of awkward space. X squared plus 2x, big old awkward space, minus 5. I'm going to add a 0 of my choosing. And by my choosing, I mean take that term divided by 2, square it, and I'm going to make my 0 like that. I'm going to add a 0 in the form of plus 1, write the addition first, and minus 1. Okay, this is almost perfectly square. I don't really want one of these in here anymore, but we have to add them at the same spot. if I make the claim that we really truly just added 2 and subtracted 2, can you guys see why I would say that? I added 1 and subtracted 1 inside the parentheses, but I think in my mind, I really added 2 and subtracted 2. Why? So it would be 2 over 2, but there's a different reason I'm looking for. What's connected to that group? Out in the very front. So when this distributes, if we were, it'd be like plus 2 and minus 2, right? So I've really added and subtracted 2, but it's still a 0. Now, we want to remove the negative term. So to do so, we'll distribute the leading coefficient, which is that a that we took initially, to the negative. To remove, and I'm just going to say there, to remove. Now, if we want more to remove from the parentheses, gosh, I wish we could finish this problem right now. We're going to do this, and this is what we're going to pick up next class. When we distribute it, help me out here. I have 2 still, and only distribution we're doing is this one. Only that one. What's still inside my parentheses then? So careful, not inside the parentheses anymore. If we distribute, we are not going to multiply by 2 again. What came out when I did this distribution? What's 2 times negative 1? So here's my negative 2, subtracting 2, minus 5. We are going to finish here Monday. If you're feeling adventurous, it'd be really cool if you would factor that.